Students online, all of you all, very good morning, everyone. Very good morning. Welcome to today's Unit 3 class. Okay, all of you all, welcome today. This, guys, we are now in topic number 12. Part 1 we have done, part 2 we have done, and today we move on to part number 3. Okay, all of you all, in part 1 we still do have certain past paper questions remaining. In part 2 also we have a lot of questions remaining. Okay, but we are going to start part 3 after our break. We will do a few questions from part 1, a few questions from part 2, and then a few questions from part 3 here. Okay, everybody. Okay, so right, everybody, can we open up part 3? Everyone over here has part 3, right? Guys online, can you all collect this copy from the chat, please? I'm doing a drag and drop right now. Very soon, guys, all this will be on your LMS itself. Okay, full-time students, maybe other subjects on the LMS. Have you all got the tutes on the LMS? I think not yet. Only IT hasn't been uploaded yet. Okay, within the next few days, IT will also be uploaded. Okay, so then you all will be able to refer to your tutes whenever you all want. Okay, just give me some time. Okay, right, everybody, let's move on to part number 3. Okay, let's move on to part number 3. Again, a few new words are coming into place. Okay, with regard to databases. Give me a second for this to open up. Okay, right. One second, guys. Right, everybody, can you come down to page number, what's the page number? Page number 4 over here. Everybody, can you all see the heading over there? We are talking about something called big data. Okay, we're going to be spending some time talking about big data. Okay, rather this whole topic is based on big data. Okay, right. Can you guys read that first paragraph, guys, and see if you all agree with it? Can you all read that first paragraph? Over the last few years, or in today's world, you can see computer systems have become a part of almost every part of our life, isn't it? One second, please. Okay, almost every part of our life, some way or the other, we have a computer connected to it. Isn't it, guys? Okay, in some way or the other, we have a computer connected to some part of our life. Okay, keep reading it. This means that data is constantly being generated. If computers are involved, data is constantly being collected and generated, isn't it? And the amount of data that is being generated by these devices is continuing to grow. Everybody agree with this? I'll give you guys some very simple examples, guys. Previously, guys, when it came to watching a movie, it had nothing to do with the internet, isn't it? Previously, when it came to watching a movie, you went, you bought a DVD, you plugged it into your TV, and you watched it. It had nothing to do with the internet. Previously, when you wanted to play games, okay, it was either you would physically go out and play your games, okay, or for example, you would play it on the computer, but that game would not be connected to the internet. But in today's world, gaming means what? Connecting on the internet, isn't it? You connect over the internet and you play with each other. Okay, it's all happening over the internet. Previously, guys, socializing meant going out and physically talking to friends, physically moving with friends. In today's world, socializing has a lot to do with a virtual world where you're moving with them, you're interacting with them, but it's all behind the screen, isn't it? In today's world, socializing heavily happens behind the screen. Okay, so this is just a simple example of how we have machines involved in almost every aspect of our life. One more example, guys. Earlier, shopping meant what? You had to leave your house. You had to go to a store. You had to physically take the items yourself. You had to stand in a queue. You had to pay it for yourself. You had to pay it yourself, and you had to bring the items home yourself. But in today's world, you can stay wherever you are, and you can have your items delivered right to your doorstep. Okay, through the internet. Okay, so you guys can easily see how much computers have become a part of our life. The thing is, when computers become a part of our life, it's constantly collecting data about you. And when it's constantly collecting data about you, it's also generating data about you. It's telling others about you, about what you're interested in, about what you purchased, about what you're playing, about how much of time you're spending on it. Agreed? It's collecting and it's generating. Are we all okay with this? Right. Can you all read the next paragraph, the bold words over there? Big data refers to the very large and complex data sets that are generated by these computer systems. It's a huge volume. It's changing very fast. It's coming from so many sources. Okay. And they are all in different formats. Okay. Look at this example on my screen now. Everyone, can you look at this example here? Can you all read these in words slowly by slowly with me? I'm going to give you guys an example of how much data does Amazon, or everyone know what Amazon is, right? Okay, Amazon collect on a daily basis. So, for example, we'll start off with user data. Now, you know, Amazon is not only what do you call a seller based in US. You don't have only what you call US citizens accessing Amazon. No, you have users from around the world accessing Amazon, isn't it? So, can you all read the first point over there? Millions of customers browse Amazon every day. Browse, okay? They go and search. Okay, how many purchase from that is a different thing. But millions of customers get onto the website every day and they search what is Amazon selling. Okay, so generating data on what they search for, what they click on, what they add to cart, and what they actually buy. So Amazon is collecting all this data. How many users came onto our site? Where did they come from? How much of time did they spend? What did they click on? What do you call, for how long did they spend on each page? After opening a page, what did they do? Which area of this page did they spend the most of the time? How many of them added it to the cart? How many of them added it to wish list? How many of them actually purchased it? Those who purchased it, how many purchased by card? How many purchased cash on delivery? Okay, like this, so much of data is being collected. Are we good? Can you guys read this? A simple example, over 2.5 billion websites visits per month, which means for a day, about tens of millions are happening. Okay, for a month, if you're having about 2.5 billion visits, then for a day, about tens of millions. Okay, then transaction data. Can you guys keep reading this? Amazon processes hundreds of millions of orders every month. We'll leave that 100 out, we'll take 1 million a month. That's a massive amount of data, right? Customer name, customer address, items purchased, delivery, what do you call, not delivery address, contact number, isn't it? Notes, okay? That's a huge amount of data, okay? Right. Then guys, Amazon also has products on their website, products that are being sold. So they have a lot of product data. And this data is changing on a daily basis. Sellers are uploading new products, changing a description, changing the price. Okay, product data itself is changing on a daily basis. Can you guys read this? They host over 350 million products. These products, the price changes, stock level changes, reviews are added. Constantly this is happening. Okay, then guys, they have device data. Devices that visit their website. Is it clear? Amazon is also collecting data about the devices that visit their website. So estimated data volume. Can you guys read this? Analysts estimate Amazon handles about, we'll say 1 petabyte to 1,000 terabytes of data every day. Okay, for a day, they are dealing with about 1,000 terabytes. That's a massive amount of data. And Amazon is just one simple example. And guys, if you think about Amazon, does Amazon deal a lot in videos? Amazon is mostly text and image based, isn't it? So keep Amazon aside. Think about YouTube. YouTube deals purely in videos, isn't it? Sorry?
But Amazon has trailer products.
Has? Trailer?
Yeah.
No, I'm saying videos are not their main product, isn't it? They are mostly text and image based, isn't it? When you go onto Amazon, it's mostly text and images. Now, YouTube is purely video based. TikTok is purely video based, isn't it? And you guys know videos consume, I mean, what do you call, video file sizes are much more than text and images, right? So then just think about the amount of data that YouTube is collecting and generating on a daily basis. Massive amounts. Everybody okay with this? This is just a simple example. Okay, can you guys look at this diagram over here? You know how I got this data, everybody? I wanted to explain the point of big data to you all. So all I did was I opened up ChatGPT and I said, give me an explanation of how much of data is Amazon generating on a daily basis. And he gave me this explanation, which I'm presenting it to you all. Then I told Amazon, then ChatGPT itself asked me, would you like me to give it to you in a visual graphic format? And I said, yes, give it to me in a visual graphic format. It generated this. Everybody okay with this? Why am I telling you all this, guys? When you all are doing your revision, sometimes, guys, now our next chapter, guys, is a bit of a confusing chapter. We learn something called containerization and something called virtualization. it's a bit difficult sometimes to explain those points. Whenever you come across something that's quite difficult to understand, use the resources available. ChatGPT is a free tool. Okay, there's a paid subscription. There's also a free part of it, which is more than enough for you all. Put these terms in it and give me a real life example that will explain this term to me. And sometimes it gives you some really good examples that makes it a lot easier for you to understand. Everybody okay with this? So big data also, I was wondering, how can I give you all an example that I can connect with you all? And then I just put in Amazon and it gave me these stats. Everybody okay with this? So try and make use of the resources available to you in your favor. Okay, guys. Okay, right. Can we move back to our tute now? Everybody, can we move back into our tute now? So everybody, I have already given you all this example. Retail and e-commerce sites, they are collecting massive amounts of data about you. Like I presented Amazon on your screen just now. Can you guys see the next one? Social media platforms. Think about Meta. Think about TikTok, guys. Guys, when you install these apps on your phone, they have certain terms and conditions with you. And basically their terms and conditions are, we are fully tracking you now. We have access to what? Your contacts, to your gallery, isn't it? They get access to so many things, to your notifications. Okay, they get access to your keyboard. Why do they want access to all this? They basically want to know about you. They want to know your interests, because when they know their interests only, they can serve you best, right? The reason Instagram is so addictive, the reason TikTok is so addictive is because it's serving you based on your interests. That's why you find it so interesting. How did they figure out your interests? By having access to various parts of your phone, to your contacts, to your gallery, to your messages, to your keyboard, to your microphone, isn't it? By having access to all these, they can now figure out what your interests are. So guys, when they have access to this of every single user, just imagine the amount of data they are collecting. It's a massive amount. And that massive amount of data is in so many formats, isn't it? So guys, can you all read social media platforms? Everybody, platforms like Facebook, Instagram, X process enormous volumes of posts, likes, shares, comments every second. Okay? Yeah. Things that are happening in that location. Because obviously, right, they are making their money from ads. So if I'm a businessman advertising on Facebook, I will tell Facebook, you know what? I'm having a cafe. Show this cafe ad to people traveling in this area. You get it? Did you understand what I just told you? If I'm having a cafe in Kohuwala, there's no point in me advertising it to everybody in Sri Lanka, right? I need to advertise it to people who live close by to Kohuwala and who are passing by Kohuwala. That's my audience, isn't it? So Meta gives me that feature. Meta says you can show this ad by location. So I can tell Meta, show this to people who, what do you call, go by this area or who live within 5 miles of this area. You get it? Okay. Right. Then guys, transport and navigation. Think about Google Maps, guys. Whether you're using Android or iOS, we are all having Google Maps installed on our phone. Okay. When you have Google Maps installed on your phone, it's continuously tracking your movements. It's tracking the routes you take. So when I ask Google Maps, how do I go from Dehiwala to Kohuwala? It's not just randomly giving me a route. It's analyzing a million routes and then telling me what is the best route for that particular time frame. Is it clear? For the time I ask at that particular time, what's the best route? It's giving me. Everybody okay with this? Have you all seen sometimes when Google Maps gives you a route, it also gives you alternative routes. It says this is 3 minutes slow, this is 5 minutes slow, isn't it? How do you come up with all this information? It has been analyzing so many previous, what do you call, users traveling this route that now it's able to give you options as well. Everybody okay with this? Okay. So Google Maps or transport and navigation apps are another example of big data. Massive volumes of data continuously changing, coming from a variety of sources. Okay, what were you going to say, Adam? Yeah.
The next time I go, the right shows the exact
same route that you were taking. Yeah. So it would have seen that your route is more efficient than the route that it has been suggesting previously. So it would have gone ahead with your route. Okay. So everybody, we are talking about big data, a few examples. Can you all move down further? Everybody, can you all come down to page number 5? Big data is made up of 5 V's. If you have difficulty defining what is big data, you can use the 5 components of big data, which we call the 5 V's. So V number 1, we have something called volume, which is basically how much. Okay, so generally big data under volume, guys, it's a large amount. Big data contains a large amount of data. Can you guys read volume? It refers to the large amounts of data generated every second from sources like social media, from sensors, from online transactions, okay, things like that. Number 2, guys, is velocity. How fast is this data changing? Everybody okay with this? The second V of big data is velocity. How fast is this data changing? If you take social media, it's changing very fast. Every second, so many users are posting. Isn't it? Every second, so many comments are being put. Every second, so many shares are taking place. Isn't it? Okay. So velocity refers to how fast is the data changing. Can you guys read that? Come on, guys. Refers to speed at which data is generated, collected, and processed. Number 3 is your variety. The different formats of data being collected. Okay, some of it is in structured format. Some of it is semi-structured. Some of it is not at all structured. It might be photos, videos, isn't it? So third is your variety. Okay, can everyone go through that? Number 4 is, these are all of you. Number 4 is your veracity. Not all your data is quality data. Sometimes, guys, you're collecting data, but the data might not be of high quality. It could come from sources that you do not trust. It could be biased. Is it clear, guys? In your big data collection, guys, not everything will be of good quality. There would also be certain not so good quality data. Okay, so sorry, like no. Sometimes you're getting data, for example, reviews. Google reviews, guys, generally we have a problem with it. People put a review when the service is really good or when the service is horrible. When things are all right, generally nobody puts a review. You get it? So sometimes reviews can be very biased. You get it? So veracity refers to the quality of your information. Okay? Can you guys read to it? Read it. Veracity refers to the quality and accuracy of the data, whether you can trust that data, whether it is reliable. And finally, guys, the value of this data. Okay, what can you do with this data? What value does this data bring to your company? Everybody okay with this? There are certain businesses, guys, their way of making money is simply by collecting data. They collect data and then sell this data to organizations that are interested in it, and they make huge money out of it. Okay, so sometimes collecting data can bring about a lot of value. Okay, now think about Facebook, Instagram. They all run on knowing what your interests are. If they do not know what your interests are, you're not going to be using that platform. You'll find it too boring. Is it clear? The reason you find it interesting is because they know what your interests are. Okay, right. So that's the 5th one is value, right? Can you guys go from top to bottom again? The 5 V's of big data. Everybody, are you with me? Can we all go through the 5 V's of big data? Okay, number 1 is how much, how fast, okay, what types, okay, the quality of it, and the value of it. Okay. Right, shall we keep moving then? So I'm going to move down then. Right. Now, guys, when you're collecting this massive amount of data, which is changing very fast, which is having so many, some of it is structured, some of it is semi-structured, isn't it? Okay, then you need to have methods so that this data is of good quality, isn't it? Then you need to make, make use of this data. So we need to consider something called your infrastructure. How are you going to collect this data? How are you going to store this data? How are you going to process this data? Everybody okay with this? Think about Facebook, think about Meta. When they are involved in big data, when they are involved in collecting so much of data, they need to have servers that can deal with it, right? They need to have storage that can store it, right? And they need to have processing power to make use of that data, isn't it? So now we're going to talk about the infrastructure. What do you need? What type of a system do you need in order to collect big data? And then what can you do with this big data? So infrastructure, how are you going to collect it and store it? And then services, how are you going to use it? Okay, everyone, can you all see the heading there? Infrastructure and services for big data, right? Can you guys read that paragraph now? So big data, you guys already know, involves gathering data from a wide range of sources. Okay, that relies on a vast array of infrastructure and services. We'll see what these infrastructure and services are. We have broken it down into three main groups. Number one is collecting it. Number two is storing it. And number three is transmitting it when needed. Everybody okay with it? You collect it and you store it. And then you need to transmit it, right? Move it from one location to another, isn't it? That's transmission. So we're going to spend some time on each part. Can everyone come down to collection? Everybody, can you all come down to collection? So collection is, how do we receive this data? How do we get this data? Okay, how does Amazon get to know about their products? How does Amazon get to know about their customers? Okay, how does Meta, for example, get to know about its users? Okay, right. Can you guys read the first paragraph there? The data in these large data sets is generated from a wide range of sources. Okay, it can be devices, it can be a source. Okay, can you guys keep reading it? Number one, guys, we get lots and lots of data from social media platforms. Okay, because almost every internet user is using social media. Isn't it, guys? Almost every internet user is also, not everybody, almost. Every internet user is an active social media user. Okay, and guys, in today's world, social media has now got connected to almost every service, right? Social media is connected to e-commerce. Social media is connected to what? Various other businesses, isn't it? Okay, so from social media platforms, a lot of data can be generated. Okay, can you guys read that? Platforms like X, Facebook, Instagram generate vast amounts of data through user interaction, their posts and their updates. Then another one, guys, we have IoT. Do you guys remember what IoT stands for? Internet of Things. What is Internet of Things, guys? Like smart appliances, isn't it? Your normal electronic gadgets, you're now connecting it to the internet, isn't it? Normally your bulb was never connected to the internet. Now you have connected to the internet, isn't it? Your fan or your AC was never connected to the internet. Now it's connected to the internet. Your door lock is now connected to the internet. So your regular electrical appliances are now connected to the internet. The moment you connect these devices to the internet, what's happening? It's collecting data about you. Isn't it? What time did you switch it on? What time did you switch it off? In what type of situations do you switch it on? In what type of situations is it going off? Is it clear? So sometimes, guys, lots of data can be collected from these tiny devices, okay, which we call Internet of Things. Can you guys read that? Everybody, can you all read that? Sensors and connected devices such as your smartphone, appliances, wearables, okay, continuously collect data about you. Okay, keep reading it. Ikram, are you reading with me? Okay, come on, guys, can you read that? For example, guys, you might have a smartwatch or a fitness tracker that's not only counting the amount of steps you're taking, it's also counting the calories you burnt, the locations you visited, the amount of time you spent over there, your heart rate, okay? And then, for example, the notifications that come into your phone, the apps that you're using on your phone, it has access to all this data. Okay, the moment you have a smartwatch connected to your smartphone, lots of data can be collected from it. Are we good, guys? Okay, right. Then, guys, from your online transactions, the purchases you make online, the websites you visit, the items you add to your cart, the items you add to your wish list, the payment method, okay, this is all valuable data for organizations. Okay, keep reading it. What are we talking about, guys? What data are we talking about? Big data. We're talking about the collection of big data. And right now we spoke what contributes towards the collection of big data. We spoke about social media platforms heavily contribute towards it. Next is IoT devices. Number 3, business transactions. When I say business transactions, I mean online purchases. When you make online purchases, guys, this data is extremely valuable for organizations. Okay, how did you purchase it? Where did you choose for it to be delivered? From which website did you come onto our site? How much of time did you spend on it? What products did you view? What products did you actually buy? Okay, this is extremely valuable information for organizations. Okay, keep reading it, guys. Then next, guys, the websites you use, the apps you use. Okay, everybody, when you use websites, guys, all of you all know about cookies, right? Whether you make a purchase on a website or not, they are tracking what you did on that website. Is it clear, guys? Whether you made a purchase or not, you are being tracked. Okay. So when you get onto a website, immediately it starts recording. From where did you come onto our site? How much of time did you spend on it? On which page did you spend most of the time? What did you click on? What did you select? What do you call? After closing our website, where did you go? Okay. Like this, a lot of information is collected. Then guys, when you have an app on your phone, that app will have access to various parts of your phone. That too is collecting data about you. Okay, keep reading it. Web servers keep track of every website, every visit to a website, okay, which can be used to analyze user behavior, okay, such as how long the user spends on a site, or if they are a returning visitor. Then guys, another way to collect data is through surveillance systems. We have cameras, we have locks. Okay, so the moment you when you go past it, it records you are present. It records how much of time you spent there. It records how often do you come that way. Is it clear? Okay, surveillance systems. Can you guys read inside it? Then guys, we get data generated from machines. These devices are automatically, continuously running. Think about satellites, guys. Satellites are continuously collecting data about, for example, traffic in an area. Okay, this is what we call machine generated data. Everybody okay with this? Then, for example, weather forecasting. We have sensors placed in various places to collect data about the weather. This is an example of machine generated data. Okay, keep reading it, guys. Everybody keep reading it. Did I show you all the Amazon? I think in ACE level I showed you all, right? Amazon's what was it called? No checkouts, no cashiers, no. I showed you all that video now. What was it called, man? Amazon self checkout. They had a slogan for it. No checkout, no. Buy and go. It was called buy and go. Amazon's buy and go. Basically, they are self checkout. So there is no cashier involved. There is no salesman there. You walk into the store, you take your items, you walk out, and automatically the amount will be deducted from your Amazon account. Okay, so you have so many sensors in that store that's collecting data about you. What you took, what you kept, what you put back, how much of time you spent. Is it clear? Okay, so this is an example of machine generated data. Okay, machines collecting data about you. Finally, guys, we have something called publicly available data. Okay, can you guys go through this? Everyone go through this. There is some data that's publicly available. Whoever is interested in accessing it can access it. Can we all go through this? Government databases, research data sets. Okay, I'll just give you one quick example. I'll give you guys one quick example. Can you all read it? Say for example, guys, everybody. I think I have given this example earlier also. Say for example, you're interested in selling smart products in Sri Lanka. You want to get down smart bulbs, smart ACs, smart door locks, smart blinds. You want to start selling IoT devices basically. Okay, and you're a businessman who's considering getting down these devices from China and selling over here. Okay, now what's your number one concern? Is the business going to work, right? Is it worth me getting down these items and selling it over here? Now, if you are interested in getting down these items, you need to make sure that Sri Lankans are what? Interested in IoT, which means what's a sign that they're interested in IoT devices? Are they searching for it? Okay, that's a very good point. What you can do is Google allows you to see what people are searching for. Google has a system where you can see what people are searching for. Okay, that's one way. You can go and see are people actually searching for IoT devices. That's one way. Another sign can be if you can prove that Sri Lanka has a high IT literacy, is that a good reason to bring down what do you call smart goods? What do you think? If you can prove that more than half the population of Sri Lanka are internet users, is that a good point for you? Isn't it? So you want to know, for example, how many people in Sri Lanka use the internet? Now, how are you going to gather this information? There are certain research, what do you call, organizations that have already collected this data for you. Why am I talking about this, guys? What did I say over here? Publicly available data. Everybody okay with this? There is also public data that's available for everyone to see here. So for example, guys, if you come here and type Sri Lanka IT literacy rate 2024, we'll take the last year, Willow. So over here, I have a website over here where it's called data report, digital 2024 Sri Lanka. Okay, so what you can do over here is you can come onto this website. For publicly available data, is the about section in any account also? No. That doesn't come under publicly available data. Okay, that data is only available. Now, for example, Facebook has it. Okay, but Facebook also gives users the option to lock their profile. So only your friends can see your about us. I'm talking the about us that I'm talking, or the publicly available that I'm talking, is for everybody. Whether you're registered on that site or whether you're a member of that site or not, you'll be able to see that data. You get it? So I'll give you a simple example over here. Now, guys, I'll give you another example. Just came to my mind. So everyone, I'm going to skip all this. You all have to read all this. I'm going to skip all this and come over here. Digital Sri Lanka 2024. So say, for example, what is our interest? Is it worth investing in smart products in Sri Lanka? So what's your concern? How many people in Sri Lanka actually use the internet? That's what your concern is, because if you have a good number of people using the internet here, then it's worth getting down these products. Okay, so let's go. So now when you come over here, now they're giving you all these information. Okay, global headlines. In the world, we have an 8 billion population. From that, 5.35 are internet users. Everybody okay with this? So more than 50% of the world uses the internet. Okay, right. Let's see what Sri Lanka situation is, Willem. This is Sri Lanka situation. Where? So in Sri Lanka, we have a 22 million population. From that, guys, we have 12 million, we'll say 12.5 million using the internet. That's more than half the population, right? More than half the population is using the internet. That's a good number for you. But guys, what is more important here? How many of them are active social media users? Because people could be using the internet, but you want to see who are active social media users, because these are people who are very comfortable with using the internet, isn't it? So shall we see what that is? So let's go to the next slide. Where does it say now? These are all, where is the, where is that information? Internet, yes, sir. Everyone, so we have 12 million internet users now. Where is social media? Social media hasn't been given over here now. Or they haven't given that stat over here. Okay, so guys, over here, this is in January. Earlier, they were giving me the number of active social media users. Now that data has been taken out, isn't it? Yeah, that data has been taken out, I think. But basically, guys, in this 12.34 million, 99% of them are using a smartphone to access the internet. Can you guys read this? Can you guys read this heading over here? Share of social media users accessing via mobile devices, 99%. That's a very good number, which means what? Users are having smartphones. If they are good enough to access the internet, they are good enough for IoT devices, right? Isn't it? So as a businessman, if you are interested in getting down what do you call IoT devices, you have enough data to back you up in getting down these devices. You can say, look, in Sri Lanka, more than half the population is actually using the internet. How did you get this data? Did you go door by door knocking, asking the people? You did not. This information is available on the internet. Example of publicly available data. I'll give you guys one more example. Guys, let's say, for example, you want to calculate your electricity bill. So normal electricity bill is calculated on what? Number of, anyone knows this? Units consumed, right? So the government has already released how they charge. If it is 1 to 100 units, this is what the price per unit is. If it is 100 to 150, this is the price per unit. Is it clear? Now guys, this information is available on the internet. It's publicly available. Okay, the cost per unit is available on the internet. Or what you can do is, you can go on to ChatGPT even and tell ChatGPT to find this information for you and calculate your electricity bill for you. Everybody okay with this? I'll give you guys a very quick example because recently I did it myself. Okay, so everyone over here, give it some time, it's loading. So everyone over here, I'll just give a question. I'll say, for example, I have consumed, we'll say 185 units of electricity here in Sri Lanka, in Colombo, Sri Lanka. Colombo, Sri Lanka. Calculate my electricity bill for me. Everyone okay with this? So now I have no time to go and find what these electricity rates are. It's available somewhere on the internet. ChatGPT will go find those rates, do the calculation and give it for me. So everyone here, here's an estimate of 185 units. I said 185. Okay, so here it's telling me for 0 to 30, this is what Sri Lanka is basically charging. Everyone okay with this? So since I used how much did I say? Since I used 185, it's giving me the breakdown of how we did the calculation. Okay, so it's going to come to about 3,498. Okay, and then guys, it's telling me there'll be a few other charges on top of it. There is tax and levies to be added of 2.5%. So finally, it's giving me, with that, it will be between 3,600 to 3,700. Okay, everybody, this is an example of publicly available data. Okay, somewhere on the internet, in some government website, they have released the rates. I have no time to find it, so I come and ask ChatGPT to find it for me and give it to me. Isn't this a part of big data? This, sorry? That concern could also be there, but generally it is up to date. Okay, because over here, what did they mention? They mention current domestic increasing block traffic, whatever. Okay, I think it should be up to date. Okay, here they're given me the sources also. These rates are based on the Ceylon Electricity Board, blah, blah, blah. And they have given me the websites as well if I want to check whether it's actually the latest rates. Okay, okay, everyone. Right, everybody. So this is an example of publicly available data. Okay, right. Can we now keep moving away from there? Everyone, let's keep moving away from there. By the way, again, let's go from the top, guys. What are we talking about today? What was our main topic today? Big data. And I told you guys, big data is what? Large volumes of complex data that's changing very fast, right? Okay. This big data is based on 5 V's. What are the 5 V's, guys? Volume, how much of it? Velocity, how fast is it changing? Variety, the different types. You have structured, semi-structured, unstructured. Value, okay, how much of, what do you call, what can you do with this data? That's your value. Veracity, which refers to the quality of this data. Not all your collected data will be of good quality here. Okay. Then guys, we then spoke about the infrastructure of collecting this data, isn't it? We spoke about the infrastructure of big data. Under infrastructure, guys, we broke it into 3 categories. What are the 3 categories? The collection part of it, the storage part of it, and then the transmission part of it. Under collection, guys, generally, where do we get big data from? Give me 3 main sources. From social media platforms, we get lots of data from there. From IoT devices. Sorry. E-commerce, online transactions. Okay, publicly available data. Okay, we get data from many sources. I listed a few now. Right, can we move on to the next one, guys? Everybody, can we move down to storage? Now comes the complex part. How do we store this massive volume of data? Everybody okay with this? Now think about this, guys. Imagine, guys, if you try to have your own data storage facilities. Now Amazon is not a good example. Take Daraz below. Daraz specializes in what? Selling products, isn't it? Their speciality is e-commerce. Their speciality is not in building server computers, agree? Daraz, their speciality is not that. Their speciality is what? E-commerce, selling products online and delivering it to the customer. That's what their speciality is. But imagine if Daraz decided, you know what? we are going to have our own facilities for collecting this data. It's going to be a very, very complex task. Because guys, first of all, guys, building your own servers is not a joke. Is it clear? You need a team of highly qualified engineers in order to build your own servers. Then it's not only building it now, after you need to configure it, you need to maintain it, you need to have physical storage space to store it, then you need engineers to keep it running, isn't it? Then when problems come up, you need your engineers to be able to solve it, isn't it, guys? Okay, then you need proper cooling, you need proper security measures. So you having your own servers is a major headache. Is it clear? And given that that's not your specialty, it becomes an even bigger headache. Okay, everybody. So guys, can you all read generally what happens under storage? When it comes to collecting big data, generally companies do something very different. They don't store data in their own facilities. They do something else. Okay, can you guys read it now? As you guys know, the name big data signifies what? The data is continuously increasing. There's no way it's going down, isn't it? The data is continuously increasing. Okay, so keep reading it. So it becomes a big challenge. How do we store this data? Where do we store it? The cost of purchasing and maintaining storage space and the need for storage capacity to be scalable. Everyone know what scalable means, no? You need to keep increasing it. You need to continuously keep increasing it. Can be prohibitive. You know what prohibitive means? Can be very difficult for you. It can be something that can be beyond your capacity. Okay, keep reading it, guys. Many companies no longer use their in-house resources. Are we okay with this? You guys yourselves are in this problem, isn't it? Guys, I think all of you all who are having smartphones over here, you all have all backed up your data where? Samsung Cloud, Google Drive, iCloud, isn't it? Your own storage is not enough to store your data. So what have you chosen? You know what? I'll pay a monthly subscription and store it on the internet. Isn't it? You guys are a simple example. Continuously your data needs are increasing. So you're not storing it on your own local storage. What are you doing? You're storing it on the internet. Okay. What do we call when storing it on the internet? What do we call it? Cloud storage. When you store your data on the internet, we call it cloud storage. Right. Keep reading it, guys. So preferring instead to make use of cloud services, which allow them to pay for the storage and systems on an as needed basis. So you pay as you go along. You pay for what you use. Okay. Right. Keep reading it, guys. Many of the large companies that offer cloud storage and services for big data also offer tools to help you with maintaining your storage. Everyone okay with that? Can you see the words there? Manipulate has come there. Everyone saw that? The storage offers you tools for you to manipulate your data. Anyone remembers what manipulate means? Our very first topic. Manipulate means what? They have tools that will allow you to arrange your data, sort your data, filter your data, organize your data based on your needs, preferences, whatever. Okay. So these, what do you call? Cloud storage facilities have features where you can manipulate your data as well. Okay. So examples, can you guys go through it? We have something called Amazon Web Service. Okay. Microsoft Azure, Google Cloud Platform. Okay. Can you guys check out this video? I'll pause it from time to time because there are some important points for you all to remember. Okay. So can everyone check this video out? Guys online, I'm about to enable sound, video sound. Okay. Previously, when I did that, students complained that the noise is very disturbing. Drop me a message if the noise is disturbing. Okay. Oh, you guys have a problem. How will you all hear? I don't have the mic now. Can you guys read the subtitles then? What I'm saying over here is, now when it comes to storage, guys, the common concept is we don't store it on our local servers. Where do we store it? We store it on cloud storage. Now, the moment you store it on cloud storage, guys, you become heavily dependent on the internet. Isn't it? You become very much dependent on the internet. Okay. So there are certain problems when you use cloud storage. We are going to deal with those soon. Okay. Can you guys read these bold words over here? Everybody, the bold words, please. As well as the storage and processing services provided by the cloud providers, big data needs storage systems to hold the data so that it can be manipulated, so that you can arrange it in a way you want, you can organize it in a way that you want. Okay, right. These systems sit on top of the cloud infrastructure and can often be used on any cloud service, allowing flexibility, accessing it whenever you want, accessing it on any device. Okay, right. Can you guys see the following now? Can everyone come down to page number 8? When you use cloud storage, guys, such as Amazon Web Services, they will have a feature, boys. Can everyone look here, girls, you all also? They will have a feature called distributed file system. Everyone okay with this? They will not store your files in one location. What do? Your files will be stored in multiple locations. What's the benefit of storing data in multiple locations? Access faster, how? Oh, guys, distributed file system. Your data is distributed across multiple locations. So how does this become better for you? I'll give you guys one simple answer. Yeah, exactly, that's one. Okay, at the same time, simultaneously you can access data from multiple servers. True. Also, guys, think about this. If one server were to go down, is it a problem? Why is it a problem? Your data is distributed, isn't it? You're having multiple servers holding the same data. So even if one server goes down, not a problem. The other servers will still keep the system running. You get it, guys? So a major advantage is what? High fault tolerance. If one server goes down, not a problem. The other servers are still running. They will still be able to provide customers with access to their data. Can you guys read that? Everyone read distributed file system. A distributed file system stores and manages files across multiple computers or servers, but to the user, they appear as one server. Everybody okay with this? When you access Amazon, guys, do they ask you which server do you want? They don't. You see one website, isn't it? When I go to OneDrive.com, guys, I see one website only. But in reality, guys, today I might be accessing a server in US. Tomorrow when I go, I might be sent to a server in India. I don't know that. But to me, it looks like it's one server. It looks like it's coming from one source. But in reality, I might be accessing different servers. Everybody okay with this? Okay, keep reading it. What are your benefits? High availability. High availability means what? Even if one goes down, the others are still available. The system will always be up. High fault tolerance means what? Fault tolerance means one going down is not going to crash the system. Okay, even if two go down, still the system is running. High, it can deal with problems. And number one, scalability here. You can increase the number of servers and decrease the number of servers without a lot of difficulty. Everyone okay with this? Can you all see the examples, guys? You all need to by heart this example, okay? There is a past paper question that asks you all this example. Boys, Himak, all of you all, can you go through it? Okay. So example can be Google file system and the Hadoop distributed file. It's not Hadoop and Hadoop distributed file system. Okay. Guys, what are we talking about? We are talking about, Ishan, all of you, what are we talking about? Under big data, we're talking about the which part of it? No. We're talking about the storage side of it, right? We're talking about the storage side of it. Under storage, what did we say? It's heavily happening on the cloud, isn't it? It's heavily happening on the cloud. Almost like 99.9% of businesses are using cloud storage. Okay, everybody. So under cloud storage, guys, we're talking about something called distributed file system, where the cloud storage provider will not store data on one server in one location. He will store the same data on multiple servers in different locations. Are we okay with this? Right. Can you guys read the next feature? No SQL databases. What does that mean? No SQL. Databases run on SQL, right? What does SQL stand for? No. SQL, structured query language. Now, database is an example of structured or unstructured data. Database is an example of structured, right? There is a structure, there is a format maintained, right? Isn't it? So when you say no SQL, you're talking about databases without a structure, isn't it? Can you guys read it? So some servers, guys, have no SQL databases. These are databases that can handle what? Unstructured or semi-structured data. Everyone okay with this? Normally databases only handle what? Structured data. But when you have a no SQL database, it can handle semi-structured and unstructured data. Okay, can you guys read it? And then guys, number 3, they will have something called data warehouses. You know what a warehouse is now? A warehouse is where you just go and dump all your products. And then from your warehouse, you start sorting, isn't it? Everybody, factories go and put their products in a warehouse. And then from a warehouse, you start sorting it, right? Okay, similarly, guys, initially when you collect your data, it might all come to a warehouse, which you call data warehousing. And then from there, you would start sorting. Okay, can you guys read data warehouses? A large, centralized, a central location to store all your business data. Okay, that's coming from various sources. Okay, your data that's coming from various sources can all be dumped in a data warehouse. And then from that data warehouse, you can then decide how do you want to distribute it? How do you want to categorize it? Okay, can you guys see the examples there? Amazon Redshift, Google BigQuery. These are all examples of data warehouses. Okay, come on, everyone. Okay, right, everyone, let's move to our third one. We are talking about the infrastructure. We saw the collection part of it. We saw the storage part of it. And now we move on to the transmission part of it. Okay, getting this data transmitted from its source to its storage. Okay, right. Can you guys read this? Can you all read the bold words over here? Refers to the moving or transferring of data in and between systems. Basically, from its source to its storage location. How do we transfer this data? Okay, right. Can you read the next paragraph over there? So big data, this large volume of very fast data in different types, okay, brings about some interesting challenges. Okay, these challenges are explored in more detail later in this section. However, some of the key issues will be highlighted over here. What is it, guys? How do we transfer this large volume of data in such a way that the quality of it is still maintained and the very nature of accessing the data will not cause issues for the user? What do I mean by this? Coming up. Okay, can you guys read this? A range of infrastructure solutions can be used to support this data transmission. Okay, these include the following. Number 1 is high bandwidth. Stop there. What does bandwidth mean? Amount of data transferred every second, isn't it? Bandwidth means amount of data transferred every second. So high bandwidth means what? A high amount of data transferred every second. That's what you mean by a high bandwidth. Can you guys read it now? So when it comes to big data, guys, generally we would be going for a fiber optic connection, a wired connection, okay, a 5G connection. Ishan, are you with me? Okay. Can you guys read that? Then guys, we would be going with, so number 1 is ensuring high bandwidth is available so that large volumes of data can be transferred in a short period of time. Number 2 is distributed storage. Why do you think we need distributed storage? Number 1 is for what? Why this? How does distributed storage make transmission better? Less traffic because your traffic is distributed, isn't it? Not everybody is accessing one server, isn't it? You have distributed your traffic across multiple servers. That's one point. Give me another point. Another point can be what? You might be sent to the server that is physically the closest to you. So the distance that the data has to travel has significantly reduced, isn't it? So Sri Lankans, for example, will not be accessing data from the US. We might be accessing a server in India, okay, which will be much shorter distance than accessing a server from the US. Everybody get it? Okay. Sometimes the location can be different. Can you guys read this? So number one is traffic is distributed. Thank you. Okay, traffic is distributed. Next is you're accessing a server that's closest to you. Okay. Right. Number three, guys, data compression. You know what compression means by now, right? Reducing your file size. Okay, everybody, we also spoke about this under what? Compression also came under I didn't get you. OSI model. No, in A2. In A2, we learned it last week. Under compression and encryption. Data backup, very close. Data archiving. When you're archiving your data, you would compress it, isn't it? So that you can save on your storage space. Big data is what? Large volumes, right? Isn't it? So you would be compressing it. So you can save on storage space. Okay, you want to minimize your running costs, isn't it? Okay, next, guys, you would be using cloud-based solutions. Are we okay with this? Everyone, can you read that? Everyone? Very rarely, I can't think of any real life examples of where organizations are using their own in-house servers. I can't. Okay. Almost all organizations will be using cloud storage to store their data. Okay. It's almost impossible for you to have in-house servers where, you know, it doesn't work that way. Okay. Right. So everybody, can we go from top to bottom now? Everyone, boys? Everyone, look here. Adam, all of y'all, when we talk about transmission, we spoke about what needs to be taken care of. Number one, you need to take care of your bandwidth. Ensure sufficient bandwidth is available to transfer this data in a short period of time. Next, after bandwidth, we spoke about what? Distributed storage, so that not all your traffic is accessing one server. Your traffic is distributed across multiple servers. Then number three, what did we speak about? Compress your data. When you compress your data, you're saving on storage space. Also, transmission time is going to go down. When your file size reduces, transmission time is also going to go down. Number four, what did we speak about? Use the cloud to store your data. When you use the cloud, guys, users can access it from their own device, from any location. Is it clear? Manipulating tools are available on it. Okay, so this all comes under transmission. Shall we go to the top again, guys? Today we are talking about big data. Big data is built upon 5 V's. Okay. After that, guys, what did we speak about? The infrastructure that's needed for big data. We broke the infrastructure into 3 categories. What are the 3 categories? Vasando, all of y'all. What are the 3 categories? Collection. Number 1, collecting the data. Number 2, storing the data. Number 3, transmission of the data. Okay, we spoke about these 3 things that come under infrastructure. Okay, can you guys come down to the next part? Everybody here, I will not be doing this entire thing. I'll be doing a small part and then we'll be doing some past paper questions from over here. Can everyone read the heading over there? Everyone heading over there, please. So everybody, above impact, can you put a word over there? A word to help you understand what impact means. So impact means what? What has it caused? What has it done? What is its effect? Okay, so can you get down one of these? What has been caused? What has been caused? Or what is its effect? Okay, so storing of big data, what has it caused? Okay, can you guys read this? Because of big data, because of this large volume of very fast data, what do you call fast changing data in different varieties, it has brought about many challenges for organizations. Can you guys read this? The massive size of the data sets presents specific challenges for organizations when storing this data. Users need to be able to access and use the data easily. Okay, and organizations have to have a responsibility to ensure that the data is protected. Okay, everybody, when it comes to big data, guys, users should be able to access it whenever they need it, and organizations need to ensure that they have put a proper system in place to protect that data from unauthorized access. Okay, easy to say in words, but in reality to do it is quite difficult. Okay, let's see. Can everyone read the first one? Number one, we have access. Accessing this data. Can you guys read it? There are a number of factors relating to accessing this data, which can vary depending on the point in the business and analysis process that the action occurs. Sounds confusing. The next point is also going to be confusing. I'll give you guys a real example. Can you guys read this? Data silos. Can everyone go through it? Big data often relies on gathering data from various sources. Various departments have to communicate together in order for big data to be generated. I'll give you guys a very short example, a very good example shortly. Can you guys read it? Can everyone under data silos, can you all put a definition there? Various departments. Various sources / departments. Various sources / departments. Accessing this data so that it can be integrated from these different sources can be complex. Everybody will understand that? Getting these data from different sources into one place can be quite complex. Are we okay with this? Okay, I'll give you all a real life example now. Okay, keep reading it. Requiring effective data integration strategies to enable data to be analyzed. Okay, I'll give you guys a very simple example over here. If you take, for example, I'll give you all two examples over here. Where's Google Chrome? If I were to take a site like, let's go to Google Willow. And if I were to take a hotel like Sheraton, for example, Sheraton Colombo Hotel. This is a very simple example, okay? When you come to Sheraton, guys, you have 500 and where are the reviews? There are reviews. I want to show you all something. Okay, so these are their reviews. When I click on view reviews, guys, now look here, Google is bringing reviews together from Google, from TripAdvisor, and from trip.com. Three completely different sources are all coming together on Google. Everyone okay with this? This is a simple, very simple example of data silos. You're getting data from three different departments, three different organizations being brought together. So this rating of 4.4 is coming by working with these two platforms as well. Are we all okay with this? So when you come over here, guys, you can see this is a review from Google. This is a review coming from TripAdvisor. Okay, and it has a 5 out of 5. If you take TripAdvisor, guys, TripAdvisor actually has a rating out of 10. So Google has to take that data and then calculate it out of 5. You get what? Did you understand what I just said? TripAdvisor, their ratings work out of 10. Google's ratings work out of 5. Trip.com, I'm not sure I haven't used that platform yet. Everyone okay with this? I'll give you a better example now, something a bit more complex. When you go on to what's it called, skyscanner.net, or if you're going to findmyfare.com, this is a platform that's working with so many airlines. Everybody okay with it? It's working with so many airlines. So say, for example, from Colombo, I want to fly to, for example, Chennai. Okay, I want to fly to Chennai. Now, when I choose this, let's just choose a random date. I want to go from the 1st and come back on the 10th. Okay, one adult, search. What type of cabin class? Economy, go. Okay, now this particular platform is working with a variety of airlines in order to give me prices for the flight that I want to go on. How do I get rid of this? Go away from here. So guys, can you all see it's working with Sri Lanka Airlines, it's working with Air India. Then guys, let me take a long flight, okay? Give me a country that will, now here, Direct flights are available now. For certain countries, guys, it's not direct flight. You have to take 2-3 flights in order to get to that country. Then what does this website do? Okay, it will then work with multiple airlines together to create one flight for you. Okay, let me show it to you all. Let me go to a longer destination from Colombo to, I want to go to, for example, to New Zealand. Okay, let's go to Auckland International Airport, search. So now over here, so now go with Qatar. So once again, it's still loading. Still loading. Once again, guys, let me finish the loading. And now, guys, look here. It is giving me a flight, but is it all the same airlines here? Here it is Sri Lanka Airlines plus Qantas. Everybody okay with this? It worked with 2 airlines to create a flight for me. Everybody okay with this? Now here both are Qantas, not so complicated. But over here you can see it's working with 2 airlines to create a flight for me. So I go from one location to another location with Sri Lanka Airlines, and then from that location to another location with Qantas. When returning, what I do is with Qantas, I come from one location to another location, then from that location to Sri Lanka with Sri Lankan Airlines. Is everybody okay with this? Yeah?
If I go abroad, sir, does my phone country change, like my account?
Account meaning which account?
Like
Your location will definitely change.
Like my account, like Sri Lanka account changed to like another country account, right?
Sri Lanka account means what? Sri Lanka account?
No, like my Google account.
Google account will be a Google account. Your location will obviously change. Google will now say you're in the other country.
But does it change like for Sri Lanka, like to Japan or something?
Yeah, it will. It will change your location.
Oh,
Okay. Now you will start seeing ads for that location. You will not see ads for Sri Lanka now. You get it? Obviously, right? Okay. Guys, why did I give you all this example? Data what? Adam, all of you all? Data what? Data silos. You're gathering data from various departments and bringing them together. Okay. And it happened quite fast, right? It took about 5 to 10 seconds, but that's generally quite fast. Everybody okay with this? Okay. So this is a simple example of data silos. I can give you all more examples. If you take booking.com, it communicates with hotels, villas, apartments. Okay. With a variety of sources, it will communicate and give you. Actually, let me take booking.com. Not booking.com. If you take trip.com, it will handle your hotel, it will handle your taxi, it will handle your itinerary, which means what are the activities you want to do when you go there. So various departments, it's working together to bring it all together in one platform for you. Everybody okay with this? This is what we call data silos. Why are we talking about it? Everybody, can you all read this again? We are talking about the impact. Because of big data, what's happening? Because of big data, what's happening? We are able to bring data from different departments together in one platform. Is it challenging? It's very challenging. Okay, it has become extremely challenging. Okay, can you guys read these data silos now? Everybody, can you all read these data silos? And then we'll do 1 point and then we have to move into past paper questions, everybody. Okay, so bringing this data, integrating it all into one platform can be very complex, requiring effective data integration strategies to enable the data to be analyzed. Okay. Number 2, guys, under access, we have something called on-demand access. I told you what on-demand means. On-demand means being available whenever needed. Okay, everyone, these are all of you all. This data needs to be available whenever needed. Are we all okay with this? Whenever the user requests, whatever country he requests, okay, booking.com needs to be able to provide him with details. Skyscanner needs to be able to provide him with those details. Okay, can you guys read that on demand? Everyone, can you read on demand? Those that use the data need to be able to use the data whenever and wherever they need it. Organizations like booking.com, skyscanner.com, Google Maps, okay, must put systems in place that allow reliable access to data. Okay, reliable means what? You can depend on it, you can count on it. Okay, keep reading it. Many organizations Keep going. Will rely on cloud service. Will rely on cloud services to provide storage system. So Google Maps, what do you call, Booking.com, Skyscanner, all of them will definitely be running on what? Cloud storage providers. Okay, keep reading it. So these providers, guys, will have limited downtime and a reliable data backup. Cross-border, I'm going to keep it for our next week, guys, because that will take some time for me to explain to you all. Okay, I'll give you guys one more example. Given you guys have noticed, right? Electric vehicles are significantly increasing in Sri Lanka, especially after this brand BYD came into Sri Lanka. So now people's concern when traveling is what? Say, for example, guys, I want to go to, give me a location. I want to go to Sigiriya, for example. Everyone, I want to travel to Sigiriya. So Google's primary function is what? To give me directions to go there. Everybody agree with this? Okay. So now what's my starting point? I'll put Platinum Business Academy. I'm starting from Platinum, and this is the route, the best route for me. Okay. Google Maps also works with Sri Lanka's Transport Authority. So it knows where the highways are. So everybody over here, I can come over here and say, avoid tolls. I don't want highways. Okay. I don't want to go on a highway. I can tick that. I don't want highways. Okay. I'll say I want the highways, Then say, for example, if I'm traveling in an electric vehicle, what is my next concern? Where are the charging stations on the way? So what does Google have? On the way, what are the hotels? On the way, where are the fuel stations? On the way, where are the EV charging points? For this route, you can also enable EV charging. So now it might change my route now. Okay, so now it shows me for your route. These are, so you can see on the way somewhere here, I have some EV charging, but then from here to here, nothing. Over here, I have an EV charging point. Everybody, can you all see this? It's now gathering data from various sources to help facilitate my trip. Everybody okay with this? Okay, right. I'm going to go away from this now.
So Ganesh, what happened if you uncheck the tolls?
It will give me a longer route now. So you are saying avoid tolls.
Yes.
So right now it's taking 4 hours, 4 minutes now. Let's say no tolls. Now your journey becomes 4 hours, 51 minutes. So now it's giving you a route without the highway. Number of kilometers remain the same. No, almost the same, no?
Yeah.
4 hour, 3 minutes became 4 hour, 51 minutes. Okay. Increase it. Can you comment take the remote, please? Okay. Right. Everybody, can we now move up, open part 1, everybody? Can we all open up part 1? Boys, everyone, can we open up part 1, please? Let's do 1 or 2 questions from here, and then let's move down.
So shall I go now? Sound please.
No, I mean, they won't have right now because I gave the part-time batch all the part 1s. Can you write down the question number and get in your writing book? Okay. Can we all come down to question number 3, please? Everybody, question number 3. One of the functions of a data dictionary is to hold information about the data objects. Okay, so for example, a table's field names, a table's field names data types, a table's field names validation rules, which we call metadata, data about your data. Okay, describe 2 other functions of a data dictionary. So one function is of a data dictionary is to hold your metadata. What are the other functions of your data dictionary? And they have asked you to describe. Everybody, what else can we mention? Sorry? Data names, and so that's your metadata now. Your table names and its fields and all are metadata, data about data. What else can we talk about? It can be active or passive. They haven't said that. They just said data dictionary here. Okay. Sorry? Maintains audits, meaning your active data dictionary can also keep records of who made changes to your database, isn't it? What changes did your database undergo? When was it made? Who made it? Okay, which we call audits. Okay, shall we get that down, everyone, over here? You can then go on to mention it can also be used to maintain audits of the data in a database. It can also be used to maintain audits of the data in a database. Something else we can talk about? Validation rules, it can be used to define the validation rules that are being used in the table. Everybody okay with this? Anything else? You had validation rules and we had something else also, right? Is it a primary key? What was that called? Well, constraints. Okay, shall you also mention that? It can be used to mention or define. It can be used to define the validation rules and constraints of a table in a database. Let's do one more and then we'll move to part 2. Okay. Everybody, boys, girls, all of you. Right, I'm moving down. Everybody, can we have a look at this one we have done? No, we haven't done, no? Didn't we do this? We didn't do it. Okay. Can you all do this then? Everybody, can you all do this? Can you all read it over here? Question 4. Part of Carlos database deals with contacts. Figure 2 shows a logical data model for the contacts part of the database. You have a contact table, you have an address table. Okay. Can we consider this as a data dictionary? Can we consider this as a data dictionary? We definitely can't. We consider this as our, what do we call this? It shows you the relationship between the table. Entity relationship diagram, or you can say logical data model, right? This is your logical data model, or like she says, entity relationship diagram. But you really can't say because we show the primary keys here. It doesn't mention the primary keys here, right? So it's safer for you to say logical data model. Okay, right. Carlos has also made some notes about the data. Marital status can be married, single, divorced, widowed. The date of birth has to be in the format of day, month, year. The date of birth has a validation rule. There are some fields which have a presence check. Okay. Create a data dictionary for contact parts of the database. Can everyone do that? Can you guys get started? So you all can first do the contact table, then you all can do the address table. Boys, girls, everyone, get started. Okay. So let's do the contact table first. So here we can call the table name contact TBL. Okay, then guys, can you mention your attributes? We call them attributes, or we call them field names. So we have contact ID, first name. Oh, actually they have identified what the primary key is, isn't it? Underlined, no? I thought that was the table heading. So then you can call this an entity relationship diagram. They have mentioned what the primary key is. Okay. So everybody, can I get started? Contact ID. Contact ID. Then we have first name, last name, date of birth. First name. Last name. Date of birth. Marital status, telephone. Employer. Okay. Right. Everybody. Then guys, can we get down the data type? Contact ID. I'm going to go with text. First name, I'm going to go with text. Last name, I'm going to go with text. Date of birth, I'm going to go with date/time. Marital status, I'll go with text. Telephone, I'll go with text. Employer, I'll go with text. So contact ID is going to be my primary key. Required, yes. What else is required? First name, last name, telephone, address. First name, last name, telephone. Everyone okay with this? You all know why I put yes, right? The question paper here, they are given me the notes. These fields must be filled. Contact ID, first name, last name, telephone. These must be filled. That's why I put yes for them. Yeah, I put yes because they have to be filled. In terms of field size, guys, contact ID, I don't know. Okay. First name, I don't know. I'll just put 50. Here I'll put 10. Here I'll put 50. 50. Date of birth will be? Date of birth, we know the field size, right? Sorry? 2 for D, 2 for M, 4 for Y. That's altogether 8. And then 2/, that's 10, isn't it? So field size for date of birth is 10. Marital status maximum, how many do we have? Married is 2, 4, 7. Single is 3, 6. Divorced is 3, 6, 8. Widowed is 3, 6, 7. So the maximum is 8, isn't it? Divorced is the longest word now. Isn't it? So marital status, your length will be 8, maximum 8 characters. Telephone, I don't know, I'll keep 11. Employer also, I'll keep 50 here. Okay. Then for data, then any notes to be added anywhere? Any notes to be added anywhere? For whom? For date of birth, mention it's a what check? Format check. Date of birth will follow a format check. Format check. DDMM Y. Next, guys. Something else you'll give a description for. Marital status, what check is that? List check. List check. Married. Single. Divorced. Widowed. Okay. Anything else? I forgot about that. Everybody, date of birth at least 18 years. We forgot that. So format check and Format check-in. Format check-in. They have to be at least 18 years. Rain check, no? Format check-in, rain check. Format check-in, rain check. Okay. I forgot about that. Date of birth has format check and rain check. Vidun, aren't you taking it down? Then guys, can you do the next table? Our next table is the address table. Over here, what do we have? Address ID, contact ID, address type. Address ID, contact ID, address type, address line 1, address line 2, town and postcode, isn't it? Town. Then guys, can you all get down the data types? Address ID, I'm again going to go with short text. Contact ID is text. Address type is text. Address line 1 is text. 2 is text. Town is text. Postcode is text. Boys, are you getting it down? Yes, sir, I don't see you noting it down. What's going on? Note it on your writing book at least. Question number 4 we are doing. Part 1, question 4. Come on, everyone. Part 1, question 4. Okay. Then who is your primary key here? Your address ID is your primary key. Any foreign key here? Contact ID becomes your foreign key here. Required address ID, contact ID. Question paper said what? Address type 1 and postcode. Address type, address line 1 and postcode required. So I put yes there. They are required. Field size, I don't know. For address ID, I'll put 10. Contact ID 10. Address type 10. Address line 1, I'll give 50 characters. 50. For town, I'll give 20. For postcode, 10. Any descriptions or notes I need to maintain? Not really, no? Come on, everyone. This is our data dictionary. Can we move on to part 2 then, everybody? Can we all move on to part 2? Anyone who doesn't have part 2, there are a few copies here. Oh, that's it. Okay, right. Everybody, we are moving on to part 2. Right. This question might take some time. We'll try to do it quite fast. Okay. So everybody, if you all can come down to page number. Question 3, please. Boys, girls, part 2, question 3. Those who don't have the tute, can you all note down? Part 2, question 3. It's about data normalization. Part 2 is fully based on data normalization. Breaking a complex table into smaller, simpler tables, and then after breaking it, what do you do? You connect them, right? You link them, you relate them. A store sells items used by swimmers. A store sells items used by swimmers. The store currently keeps records of sales in a spreadsheet. In a spreadsheet, they are recording all their purchases. Figure 2 shows some of the recent records. Manufacturers are listed in brackets in the stock bought column. Everyone, did you all understand that? Goggles is the item and Majestic is the what? Manufacturer, right? They told you in brackets we have the manufacturer's name. The store wants to create a database to store this data. Okay. What do they say? Create table showing the database in third normal form. Primary keys must be underlined. Foreign keys must be indicated by an asterisk. Do not include any data in the tables. Okay. So everybody, how are you going to normalize this? What is the first table you would like to separate or you like to create? Order table. Customer table is the easier one to create first, isn't it? Shall we start with customer table? Isn't it? We'll first break this into customers. Agreed? Okay, we'll first break this into customers. So what I'll do is, first I'll do a draft. So guys, tell me what do you think would be inside the customer table? So we have a customer TBL. Customer TBL, tell me what would the fields be? Customer ID, good start. First name, customer. F name, customer. L name. You know why we did that? Because in third normal form, fields must be atomic, meaning you should not be able to divide it anymore. So instead of saying customer name, you say customer first name, customer last name. Excellent. All our customers are in a single table now. Next, go for what? Order. Keep order last. Order is going to connect everybody now. Stock. Shall I call it items table or stock table? Whichever. Stock table. Okay. Stock means items that we have. Okay. Before that, guys, I shouldn't do this. Oh, I'll do it. Stock table. Stock table means the items that we are selling. So what will the fields be? Stock ID. Keep going. This side, this column. If you have stock ID, also need. Girls, boys, all of y'all. Every stock, if it has an ID, you also need to have a what? Examples of stock are what? Goggles, earplugs, towel, earplugs, caps. You need to have a stock name, right? You need to have a stock name. Anything else? Manufacturer. Are you sure manufacturer name? Quantity, not here. Quantity will come in order, isn't it? Why will you put the quantity in stock? Are you mean quantity available? A quantity available? Okay, that's a different. I thought you were saying how much the customer bought. But quantity available can be. Are you going to put the manufacturer's name here? Manufacturer ID makes sense. Imagine Majestic will be look here. Majestic will be repeated so many times now. It's not a good idea to repeat the name, right? Repeat the ID, isn't it? So everybody, we will have manufacturer ID here. MAN manu ID here. Agree? 1 minute. In customer table, who is your primary key? Customer ID. In stock table, who is your primary key? Any foreign key here? Manu ID, isn't it? Manufacturer ID will be your foreign key. It's going to come from the manufacturer table. So obviously your third table now will be manufacturer table. Tell me the fields here. Very good. Your manufacturer ID. Your number one field will be your menu ID. Menu ID, which will be your primary key. Go on. What's your next field? Menu ID. Not ID mean name. Menu name. Your manufacturer's name, right? Then you're going to connect all of them using order table. You now need your order table, isn't it? Tell me what are the fields in your order table? Something interesting is about to come up now, which I have not done with you all ever before. So order ID, awesome. Order date, excellent. Yeah, I heard you said, Yavan, what did you say? Custom ID, I agree with you. Keep going. Stock ID. Now you guys slightly messed this up for me. Anything else? Nothing else? Quantity here. Now here is my question. I'll start with the easy question. I'll ask the difficult question first. Who's your primary key here? Order ID. Customer ID. This customer bought 3 items. His customer ID is going to repeat thrice. Order ID. This customer, under this order, we bought 3 items. The order ID is going to repeat thrice. Did you understand what I just told you? In every record, we are only going to record 1 purchase now. We don't agree with me. So if I make order ID my primary key, what's going to happen? 31890 is going to repeat thrice because he bought goggles, earplugs, and towel. Can you repeat your primary key? You can't. So how are you going to uniquely identify every record? Very nice. Composite key. Which 2 fields together will never repeat? Very nice. Order ID and stock ID together, will they ever repeat? Order ID and the stock ID together will never repeat. Agree with me on this? If I take only order ID, boys, look here. If I take only order ID, it will repeat now. Look at this. In this order, goggles is 1 record. The same order, earplugs. In the same order, towel. Agree? So order ID is repeating. So you can't make order ID your primary key because it's repeating. What if I do this? The order ID and the stock ID will work together as primary keys. When 2 fields to work together, what do we call it? Composite key, right? The order ID and the stock ID together, will they ever repeat? Answer is no. Did you understand? Understood, right, everybody? So here in this table, guys, I'm going to make what? So we'll put 2 lines. Order ID and stock ID are working as composite keys. They will work together to identify a record. Then, guys, who are our foreign keys here? Customer ID here. Now, guys, this is only your draft. Where do you put the actual diagram? In the next page. You all know that, right? My time is up. In the next page, you all have to properly draw the tables, indicate, and then have a key. Double line means composite key. They have given you, right? They have mentioned here, primary keys must be underlined, foreign keys must be asterisk. Everybody, in the next page, you draw the proper tables. But do you have to show the relationships here? Do we need to show that? No. Did they say entity relationship diagram? You don't need to show the relationships, but doesn't matter. You can do it. You're not getting any marks for it though, because they didn't say draw an entity relationship diagram. They said show the table, the database in 3rd normal form. Okay. Composite key. So what you do is you only show primary keys. So for the order table, there'll be 2 primary keys. Okay. You underline the 2. Correct. Everyone, this is a draft. This is not your answer. This is only a draft because otherwise I have to scroll up and down. No, that's why I put it here itself. Your actual answer must come here. Your actual answer must come here. Okay. I just did it here so I don't have to scroll up and down.